This is the introduction to verifying trig identities. Here are some helpful hints for you want to write down. Number one, you typically want to work with one side and one side only of the equation. Choose the more complex side and simplify that. Number two, use your trig identities, especially the Pythagorean identities, is the most common. Number three, split up a fraction at times. Number four, you may need to factor, add fractions, square a binomial, or find a common monomial denominator. Number five, convert the left or right hand side to all sine or cosine functions. So here's some helpful hints for you. So question number one, how do we verify an identity? So this will be your essential question. So the first thing we want to do is we want to verify this equation. Is it holding true that the secant of x times the cotangent of x does really in fact equal the cosecant of x? So the hint that we're going to give you here is to rewrite one of the sides into all sine or all cosine. So you want to start with the more difficult side. So this looks like the more difficult side, the left-hand side. So if you remember, this secant of x can be written as the reciprocal identity of 1 over the cosine of x. Then this trig function, trig identity, cotangent of x, can be rewritten as a quotient identity of the cosine of x times the sine of x. And we're leaving the right-hand side alone. So now we have a fraction times a fraction. Look at the two fractions. They're multiplying each other. We can go ahead and cancel a cosine of x from this numerator and that denominator. Now we'll simplify it. We have 1 over the sine of x. Again, we're only working with the left-hand side. Now we have one more identity, the reciprocal identity. 1 over the sine of x can be rewritten as the cosecant of x. Now we want to see, did we end up with this right-hand side? This right-hand side, I'm just dropping it down. We've shown then that the left-hand side of the secant of x times the cotangent of x does in fact equal the cosecant of x. Here's a second example. We want to verify that 1 plus the cosine of x over the sine of x equals the cosecant of x plus the cotangent of x. So what I'm going to do is I'm going to start with this left-hand side. And I'm going to split up this one large fraction into two separate fractions. So I have 1 over the sine of x plus cosine of x over the sine of x. And what I want as a result is this right-hand side of the equation. All right, now if you remember, 1 over the sine of x, right here, 1 over the sine of x is the reciprocal identity. So that can be replaced with the cosecant of x. This cosine of x over the sine of x is a quotient identity with the cotangent of x. So let's look and see. Did we end up with the cosecant of x plus the cotangent of x? Yes. Just go ahead and bring that down. They do, in fact, equal each other. So we verified using the identities. Third example, we're going to work with the Pythagorean identities. Again, we will give you a blue, purple sheet, or whatever color sheet we give you, and you can not have to memorize all these, but we do recommend it's helpful to memorize them. So what we're going to do is you want to verify that the cosine of x times the cotangent of x does in fact equal 1 minus the sine squared of x over the sine of x. So I'm going to start with this right-hand side. And I'm going to replace 1 minus the sine squared of x with the Pythagorean identity. If you remember, sine squared of x plus cosine squared of x equals 1. If I solve this for the cosine squared of x, that means I'm bringing the 1 minus sine squared of x. So this is going to replace here. So my numerator now is the cosine squared of x. And then I have over the sine squared of x. Now I'm going to go ahead and separate out this large fraction into two separate fractions. So I have the cosine squared of x over 1, and then 1 over the sine squared of x. All right, now I can go ahead I'm going to go ahead and then separate out the cosine of x over 1, and then the cosine of x over the sine squared of x. So I have 1 cosine of x here and 1 cosine of x here. So this now simplifies down to the cosine of x let me check here. This should only be, this should be the sine of x. No wonder I was trying to take a break here going, what's going on? So let me just fix that here for a second. So this should be the sine of x. Go ahead and fix yours. This should be the sine of x. And then this should be the sine of x. Alright, so now cosine of x divided by the sine of x is the quotient identity. So now we have the cosine of x times the cotangent of x. And this is what we wanted up here. So I'm going to go ahead and bring this down. Cosine of x times the cotangent of x. Sorry about that. One left. We want to verify these two identities. So one thing we can do is replace this with the Pythagorean identity, which is secant squared of x. We can replace this with the Pythagorean identity, negative sine squared of x. And we're leaving the right-hand side of the equation alone. Now this is the reciprocal identity of 1 over the cosine squared of x. And then this is also the reciprocal identity, but I'm going to leave it alone for now. So I'm going to keep it with sines and cosines. All right. Now what I have is a fraction times a fraction. I'm going to go ahead and combine them together. So I get negative sine squared of x in the numerator, and I get cosine squared of x in the denominator. All right. So if I look up here, I'm getting close. I want my final answer to be negative tangent squared of x. Well, right now I have negative sine squared of x over cosine squared of x. This is the quotient identity. So I go ahead and simplify this as negative tangent squared of x. So I finished. I wanted this, negative tangent squared of x. So I've proven that these are in fact identities.